analysis of question 9 here. So this is about redox, of course, just by looking at that table there. So this question is about vanadium compounds and ions. Now this is a very common topic of redox questions, vanadium, especially for AQA this. So use the data from table 4 to identify the species that can be used to reduce VO2 1+ ions to VO 2+ ions in aqueous solution and no further, and explain your answer. Well, checking out the table here, I mean, they've played their usual trick. What they've done is most positive at the top and then most negative at the bottom. So in terms of application of the anti-clockwise rule, they've just made it more difficult for us. Okay, so when they've done this, it sounds crazy, but your anti-clockwise rule becomes the clockwise rule, doesn't it? Okay, so we're going to expect, because we've flipped this over, we're going to expect it to go from, where's our VO2 1+ ions? Here. Okay, so we're going to expect it and go over the top here to go this way. So what we're looking for is something underneath to go this way. But we want to make sure that it reduces VO2+ ions to VO2+ ions, but then no further. So we don't want this one to happen as well. So you need to select one of these three, 1, 2, 3, that will reduce it, but then of course not reduce VO2+ to V3+. So you're looking for something with a value, an ENROL value that's going to do that, and that forms your explanation. Which one of those have you chosen and why? Okay, so if you just see if any of those actually work, and then we'll see how we go. In fact, looking at the table, it's not actually most positive to most negative, because it's almost like two separate tables, if you like. Okay, we've got our vanadium ones up here, but then we've got the other three reagents, so the chlorine, the iron, and the zinc, that they're in a kind of separate table of their own, most positive to most negative. So I'm just going to do that. We want to think about it like this. Okay, two separate tables there. 9.2, give the oxidation state of vanadium in VO H2O5 2+. Well, for me, this H2O5, that's a bit of a red herring. I'd almost imagine that that wasn't there, because each H2O, well, they're overall, in terms of oxidation state, 0. Okay, so if you imagine that the H2O5 isn't there and you end up with VO 2+, well, that's much more easy to actually deduce the oxidation state of vanadium in there. Over the page onto something slightly different, the VH2O4Cl2 1+ ion exists as two isomers. One of the isomers is shown. Draw the structure of the other isomer and state the type of isomerism. So if we notice, we've got these two chlorines kind of bottom left and at the bottom, or if you like 6 o'clock and 8 o'clock, and they're next to each other. But of course, there's another form of this complex ion whereby they are not next to each other. So where are you going to move one of those chlorines to, and what type of isomerism is it? Now be careful when naming that type of isomerism. I'll give you a clue. It's going to be stereoisomerism, but you need to say what type of stereoisomerism. Stereoisomerism on its own will not get you the mark. 9.4, heating NH4VO3 produces vanadium 5 oxide. So what's the formula for that? That is V2O5. You should know that one actually, because it's used quite a lot. Water and one other product. Give an equation for the reaction. So because we're heating NH4VO3, that's going to be the only reactant, and it's given us 2 of the 3 products. So yeah, we should be able to deduce what that is. Maybe a little bit of balancing required here too. So 9.5, last one in this question actually, vanadium 5 oxide again, V2O5, is the catalyst used in the manufacture of sulfur trioxide. Okay, so sulfur trioxide is SO3. Give 2 equations to show how the catalyst is used and regenerated. So those are your 2 equations there. Now I'll give you a clue. when we manufacture sulfur trioxide, it's from sulfur dioxide. So that's going to be your first equation. How does V2O5 actually help convert SO2 to SO3? And then what actually what do we actually get as a product of that? What does our catalyst turn into? But then how is it regenerated? All right, so 1 mark there for 2 equations, and of course they need to be balanced as well. So yeah, I think around the houses a bit with this question 9. It's all about vanadium for sure, but there's some redox in here. There's some isomerism and some equations to actually to balance and to write as well. So they're a bit nondescript, 9.4 and 9.5, but nothing too taxing here. It's 7 marks. I think you should be pretty confident in getting all of those marks. There's nothing really crazy in here or difficult to understand. So well, we'll see how we get on, shall we? Make sure you subscribe to our channel so you can keep up to date with all our new content. If you like this, you'll love our free trial. Click the link and check it out. You've now got 2 choices. You can wait and see what YouTube randomly throws up, or you can improve your grade in under an hour by checking out my awesome chemistry transformation playlists.